perfect and most appropriate lecture to have right after lunch, because it is about key nutrient gene reactions. Like, what are the genes that affect your nutrient levels? Yeah. Food, what you eat, has a huge effect on your nutrient levels. But there's some other things. So, learning objectives for this talk. I want the practitioners to understand the relevant current research on the risk alleles. So we'll talk about the alleles that we've seen through the relevant research to have a connection between nutrient levels. Also, I want to look at, because we test on a lot of vitamin D genes that Dr. Knapp touched on or talked about a lot, I want to talk about those and how they interact. And then talk about treatment considerations, just so that you know if a person does have a risk allele, what's a good treatment consideration. Because what's really interesting about these risk alleles oftentimes is that there's one specific part of raising nutrient levels that they are involved in. And if you can identify that part and bypass it or support it, then you can quickly and effectively raise a person's nutrient levels. Foods. Foods rich in nutrients. There's the first thing we need to do. Decrease beige food, increase colorful food. If there's the quickest way to explain to somebody on how to eat, it's just to look at what the color is. Yeah. I remember they were doing some studies where they were showing pictures. Did you guys ever see this, where they showed pictures of each, like, different cultured families? So, like, they had some people in, like, Belgium or France, and they, like, showed in front of them all the foods they ate for a year. And it was like pictures, and you could just see them back to back. And then there was the Americans that had the pizza and the soda pop, and then there was some people in a country in Africa, I can't remember, but it was a big, great bag of rice. And it was really interesting just to visually see the color spectrum represented there. So nutrient deficiencies. Is there such a thing as a nutrient deficiency in a developed country? I had this argument with my dad. He has his master's in biochemistry, and some already know the answer right off the bat, but he says, oh, core, that's not a thing. The nutrient deficiencies is not a thing. And I'm like, why? And he's like, because our food is full of nutrients and we eat lots of it, you know? And I'm like, okay, yeah. let's talk more about that. Obviously, what you eat, I talked about the beige foods. But here's the thing, like, if you have a patient who's taking a supplement of B12 and their levels are still low, then you start to wonder there's a lot more at play than just what they eat. So there was a CDC study that was performed in 2012 to show that the top nutrients that people were deficient in. And some of these probably aren't very surprising to you. You know, B6 and B12 are really hard to absorb. They require a certain level of stomach acid. They require intrinsic factor. So the fact that people are low in them is not a huge surprise there. Vitamin D you get a lot from sunlight. Now, if you're prone to running around outside naked, this might not be an issue for you, or if you don't live in the Pacific Northwest. If you don't do those things, then you might be low in vitamin D. In my practice, that's a part of my routine blood work. Every year, every patient that I see gets their vitamin D levels checked because they live in Oregon or Washington, or wherever it is you practice. Iron, this is a very interesting one too. You know, there is a lot of people who are iron deficient. It's mostly an issue in menstruating women in a certain age group. So if they're menstruating and if they're menstruating hard, then that is a good nutrient to check. But there are a lot of other people in this world that have low iron, and having low iron levels can be a symptom of chronic disease. So vitamin A, E, and folate. Folate, where do you think foliage? This is a nutrient that's you're getting from if you're not getting it from synthetic folic acid that's been added to your food, in nature you would normally be getting it, and I have a list of foods, but you'd be getting them from dark leafy greens and vegetables and different things. So no surprise there are some people who don't eat a lot of that in this country. So what are factors that influence nutritional status? We've talked a little bit, I just talked about this, the composition of nutrients within foods, but then also too, to just take that one step further, you could be growing a very nutritious food in a very nutrient depleted soil, not soy, but the ground doesn't have a lot of nutrients for this plant to take in and put into itself. And that's a huge problem in these farming communities that are using these same soils over and over and over again, and there's not that variety or adding back of nutrients. Absorption is a huge issue, especially in this day and age when we're talking about leaky gut syndrome. That is going to just destroy your barriers and decrease the factors that help bring nutrients into your bloodstream and then take it over to the liver. And then another big thing, and especially on a genetic level, is the metabolism of these vitamins into their active forms. A lot of these supplements like D3, this is not the form that your body's using. This is the form that your body takes and turns into the active form. So there may be a breakdown in that process as well. And then circulation and transportation of nutrients. Sure, you're taking it in, it's getting into your bloodstream, but how does it get to your tissues? On those little school buses that we learned about in school. Yeah. Signs and symptoms of nutritional deficiencies. Again, I kind of touched on this, but these are really going to be things like mental fog, low energy. These can be some vague symptoms in some respects, but you take them in as a whole picture. If you have somebody with low energy, muscle weakness, brittle nails, that pale skin, pale mucosa when you pull down their eye and you look to see if they're anemic, slow blood capillary refills. But a lot of times, honestly, a practitioner is going to pick them up on lab work, routine lab work. You can have trouble seeing in the dark, night. You know, if you ever have a patient that says, I can't drive at night, they would check their vitamin A, make sure that they're utilizing that, converting the beta carotene into retinol, which we'll talk about. And then most important sign, again, is going to be that lab work, and that shows a sign. It's a sign of a nutritional deficiency, which could be related to a genetic susceptibility, and that would be a great time to start looking at these nutrient-related genes and risk alleles. So you have a patient that's low in B12, you're supplementing them orally with B12, their levels aren't going up, and you think, what's going on? So we're going to go through each one by one, and we're going to start with vitamin A. There is a gene, the BCMO1 gene. This encodes for an enzyme that helps take beta carotene to retinol, which is the active form of vitamin A, through this pathway. If you don't have this, and I don't know if you guys have heard of this before, but you're not going to be a lot of the people who get their, the beta carotene from carrots. There's that big movement like, eat carrots, get your beta carotene, or they say vitamin A. A lot of the supplements of beta carotene, they require this enzyme to take them to the final step. So a lot of times people will say, oh, you shouldn't be getting your vitamin A from that form because you don't know if you can convert it into retinol. Well, now you can test to see if the person can, because the sources of retinol can be more meat-based. And if you have a person who's a vegetarian, that's going to be something you might have to have a talk with them about. But vitamin A insufficiency and deficiencies, this is definitely a thing. This is within the population, and you can see certain populations suffer more from it. This is at risk is in the green, and at risk for inadequacy, and then at risk for deficiency is in the blue. And this is your percent chance of it. So certain, females are slightly more at risk than males. And so you can see there are risk factors if you're pregnant or lactating. Vitamin A is important, and a deficiency in it is definitely possible, even in our society. So the wild type, or the normal type, the normal functioning type of this gene is the TT alleles. If you have GG, this is associated with a decreased enzyme activity and an increased risk for active vitamin D deficiency. Yeah.
But what about other sources of vitamin vitamin A, such as eggs? Is that a problem to say?
No, because like in liver and I believe eggs, there's a list I think I have in here of foods where you can get retinol, and you're getting retinol. So if you're taking in retinol, then this issue is no longer, yeah. But if you're getting it from vegetables, it's usually beta carotene and you can't convert it. So good point. You've already figured out my treatment recommendation. So beta carotene versus retinol. Retinol supplements dosing. Most of the supplements are beta carotene. Sources high in retinol, fish, cod liver oil. That was the number one that I saw out there as a recommendation, was that cod liver oil, meat, poultry, eggs, and dairy. And I know there is some debate out there about liver oils or liver as a supplement having too much vitamin A, because there's absolutely a threshold for vitamin A that you don't want to go over, especially in potentially pregnant women or pregnant women. And there is one case of I think a gentleman who was lost in the Arctic, and he wound up consuming his sled dogs, and he died of vitamin A poisoning because he ate their livers, and it was just too much for him. So there is that possibility. So do not recommend sled dogs as a food source for your patients. There, see, you're getting your money's worth for this already. Yeah.
There was
Bear liver, huh?
There was a hunter who kind of, hunted a bear, ate the liver,
Oh.
and he died. And so the joke was that the bear had the last laugh.
Oh no. Yeah. So moving on to the next one, B12 levels and FUTS1 and FUTS2. So there's a gene, the FUTS2 gene, that codes for an enzyme that is associated with B12 absorption from the gut. Has anybody ever heard of secretor, non-secretor status? Yeah. This is the gene that determines your secretor or non-secretor status. What that means is that you could secrete your blood type into your secretions. What is your blood type? It's that sugar that sits on the outside of the red blood cell, right? That's what determines whether you're A, or if you have nothing, you're O, or you're B, right? That sugar can actually be cleaved and secreted in your secretions, and it affects the bacteria that live in your gut. Now, they don't know the exact mechanism of why it has such a profound effect on B12 levels. There is a proposed mechanism because it affects the gut flora. That is what maybe increases or decreases your absorption of B12. I believe it has an effect on your H. pylori levels, is what one study was showing. So making that connection is still out there, but it's a really interesting gene to study. If you guys ever want to study up on one of these and go down the rabbit hole of secretor, non-secretor status, because you have tons of free time, this is a great one to do that. But what they found is that a certain genotype was associated with lower serum B12 levels. Why? Because they weren't absorbing them as well. So what's the way around that? B12 injections or sublingual B12. You really want to focus on that. And that, I mean, I know that a lot of times you just wind up doing that as a practitioner anyways if you think they're low in B12.
Since we have a number for patients with autoantibodies against intrinsic factor, you have to bear in mind that as well.
Like pernicious anemia, kind of?
Yeah.
Yeah, absolutely. Yeah. So the variants can give rise to a non-functional enzyme, and then that causes an inability to secrete your blood type into your secretions, and again, that's going to affect your blood sugar levels. So the non-secretor phenotype, the one that does not secrete their blood type into their secretions in their GI tract, they are associated with higher or normal B12 levels in the blood. And the secretor status, which is the bulk of people, I think it's 80% of people are secretors, they are going to be more susceptible to low B12 levels. Treatments, again, is going to be bypassing that absorption, the digestion. Bypass your digestion, go straight into the body. So IMs, infusions, liposomal B12, possibly. I don't know about the research on this one. It's just something I threw out there as a consideration. Vitamin D. So these are all the genes that we've talked about. There are several genes that are involved in vitamin D regulation. And Dr. Angela, she talked a lot more about these in depth, but they have to do with decreased conversion into the active form, transportation. One actually has you using the substrate for vitamin D to make cholesterol instead of vitamin D. And then there is some about the VDR, which is actually the vitamin D receptor and its ability to receive the message of vitamin D. So they kind of are all, these genes sort of surround all the different ways, basically all the different things that could go wrong in utilizing vitamin D. And you can see here, this graph sort of summarizes all the places that these genes affect. So this is the precursor to vitamin D. This enzyme can make it go over here to cholesterol more than making it go over here to the pre-vitamin D precursor. This enzyme, CYP2R1, is incredibly interesting. It's the second to last step in the metabolism of vitamin D into its active form, calcitrol. If you have 2 mutations in this gene, it's one of the quickest ways to get their levels back up, get the patient feeling better, is just to prescribe the calcitrol. It's a prescription medication. You could just start off with the lowest dose once a day and see if that helps their levels, if they're just not coming up any other way. Then you also have this transport gene, the GC, which is just carrying the active form of vitamin D around the body. So you may have this person whose vitamin D levels are fine, but they're not transporting it to the tissues and utilizing it properly. So you want to be kind of watching this whole process, especially since vitamin D has so many different actions in the body. And here's a little table that kind of summarizes all of these because there's several genes involved in vitamin D. So if this is the way your brain works in organizing information, this is a really great table to show that metabolism and show how the effects, like a lot of these VDRs are associated with osteoporosis, which we were talking about in the graceful aging section. So what are some treatment considerations? Depending on the mutations, but a lot of these mutations where you have like a slow enzyme or it's not binding to the transportation mechanism very well, there's not a lot of research to say supplementing exactly this way is going to bring it up. We need more research on that. So as a physician, I kind of surmised in my mind that if you're giving them low frequent doses of vitamin D, then if their enzyme's slow, at least it's being fed constantly. Do you see what I'm saying? So like if you're gonna dose your patient once a week with 50,000 IUs, do you think that's really gonna be good if you have a slow enzyme? No, you're probably gonna be wanting to do 1,000 IUs twice a day or 3 times a day. Yeah, so you can just keep up with it. Or you can try prescribing vitamin D through sunlight if you're thinking that possibly they need a later step in a metabolism pathway, or maybe say the transportation enzymes are overwhelmed. If it's being made in the tissue and then transported that way, sometimes sunlight can really help as opposed to supplementation through absorption issues. And prescription, like I was saying before, that enzyme CYP2R1. Sometimes you just have to treat it with a prescription form of the active vitamin D. Iron, TMPRSS6. This gene is very interesting. It produces a protein that is involved in a signaling pathway. Well, this influences your ability to absorb iron through the diet. And there can be oftentimes people can be really low in iron, and this is definitely one of those cases where you are taking iron and you are giving it to your patient and their iron levels are not budging at all. They will not go up. And it was interesting because when I searched for treatment solutions to this, I found one case study of like a 9-year-old little girl where they had been giving her iron through the blood. They had been giving her iron as a supplement, and it wasn't until she took liposomal iron that her levels actually started to respond. So it has something to do with that way of absorbing that iron that helped her, and she had a mutation in this gene. So that is one thing I was like, okay, this is where I would go if I were to build a big study to test to help people with this condition. I would probably start looking at liposomal iron supplementation. MTHFR. This one's a very interesting one, and I know most people have heard a lot about this mutation, or this gene, and I know Dr. Knapp talked a lot about it too, but this one encodes for an enzyme that helps convert 5,10-methyl tetrahydrofolate to 5-methyl tetrahydrofolate, 5-MTHFR. Basically what that means is that this enzyme can have reduced activity with the risk allele. So what do? You just feed the person the next step in that biochemical pathway. that enzyme pathway. You just bypass this enzyme. Basically, like if you have a lazy teenager, fine, you're not going to pick up this, then I will just bypass you and do it myself and you don't get your allowance. I don't know. But that's basically what you're doing here, is you can see where the problem is in the enzyme pathway, and you can just give the person that next substrate, and they're not reliant on this enzyme. You can really treat a person very quickly just by understanding that tiny little key part of their biochemistry. So what are some foods high in methylated folate, like folate that's already ready to go and doesn't need this enzyme to convert it into that substrate that's used to recycle homocysteine? This is, I didn't know this. Did you guys know this? Garbanzo beans is actually really high in folate, which is great because we had hummus today and that was planned, right, Kate? Yeah. Lentils, avocados, beets, spinach, liver again, pinto beans, asparagus, and black-eyed peas. So making those connections, the SNP interactions. Vitamin genes, there's a lot of interactions there. But also vitamin A and vitamin D, there's interactions, and then no surprise, anybody who's ever looked at a CBC and looked at the red blood cell, the size of somebody's red blood cells, knows there's a connection between B12 and iron. So what if you have more than one risk allele? What if you have a patient, like when I got, just to pick on myself, when I got my nutrient panel back, I had a risk allele in every single vitamin D gene out there. So I immediately was like, okay, well, first off, that explains my lab tests. I thought it was just because I hate the sun, because I hate it. It burns. So I was thinking I need to lay out in the sun more, but now I realize this is much more than that. It's a bigger picture, and I need to be taking a supplement. And what I do is I take a supplement that I take frequently throughout the day, and just little drops of it, like maybe 2 to 3 times a day to keep my levels up. And so that's the thing, is you're putting all of these together, and it's just showing you this person has a major weakness in that one area. So that's one way to look at it. So what if you have a defect in both your vitamin A absorption genes and then also your ability to maintain your vitamin D levels? Well, vitamin D and vitamin A, there's a proposed effect that they have together on your immune system. So you can see a person with a weakened immune system if they don't have enough vitamin A and vitamin D in their body. And because this helps with normal genetic function of the cells. Also, a connection between iron and B12. We know this. You need iron and you need B12 to have a normal level of or normal size and development of the red blood cell. And when we were talking about pernicious anemia, one thing about pernicious anemia is that they have both B12, low B12 and low iron levels, and that's what causes the anemia. So you can have microcytic anemia, which is caused by low iron, or macro, which is caused by the low B12, or you can have, if you have both, I believe the manifestation is microcytic anemia. Just look that one up too, sorry. So, system interactions. Because this is nutrient, because I'm talking about each gene individually, like what nutrient does it affect, I like to kind of try and bring that back together and look at the systems again. But it's really going to have a huge, if you're not a nutrient-rich person, I know I shouldn't even have to say this to this group, definitely, but it can affect a lot of different systems. Your cardiovascular system, your ability to metabolize just even fats and burn energy has a lot to do with B12 levels. Your brain health, vitamin D, seasonal defective disorders, your gut health. You really need to be able to, that affects everything in your nutrient absorption. Bone building, your ability to, vitamin D is so key to bringing in calcium and to build bones and your immune response. So it really has an effect on the entire body. So kind of just wrap it up and cover and go over what I just said. Yes, it's possible to be nutrient deficient in the United States of America. They're kind of hard to diagnose because the symptoms can be very vague. You often first see this in lab work. And then there are certain genes that are related to certain genetic deficiencies. And understanding that patient's biochemistry can help you get a very targeted, exact treatment plan that gives you the results that you want in your patient quickly.